Hi everybody, coming at you here with just a quick section today. We're going to talk about classifying triangles based on their coordinates. So without any graph paper, without any measurements, only using the coordinates of the vertices of a triangle, we can say whether it's scalene, isosceles, or equilateral, and we can also say whether it's obtuse, acute, or right. We've done all of this stuff before, but we're going to put it together today specifically talking about classifying triangles with those coordinates. So in this first example, we're going to show how to prove that 3 coordinates make a right triangle. In each of these examples today, we're going to do the same process. The first thing that we want to do is we want to figure out the side lengths of this triangle. We only have the vertices, but we can use the distance formula to find the side lengths. So with vertices A, B, and C, that means that we're going to have a side AB, that's the side between point A and point B. We're going to have a side BC, and we're going to have a side AC. So we're going to figure out the distance between each of these points, which would give us the length of each of these sides. So for AB, we'll go in and we'll do the distance formula. So the square root of x2 minus x1 squared, that's negative 6 minus 6 squared, plus y2 minus y1 squared, so 9 minus 4 squared. I like to go through and do each of these first and then simplify. That way I'm not looking back up at the coordinates each time and getting confused there. So I'm going to go through and do BC. So for BC, we've got x2 minus x1 squared, so 0 minus negative 6 squared, plus y2 minus y1 squared, so 0 minus 9 squared. And then for AC, x2 minus x1, so 0 minus 6 squared, plus y2 minus y1, 0 minus 4 squared. And now that I've got all those, I can go through and simplify each one. So here in AB, I have the square root of negative 12 squared plus 5 squared, and that's going to give me 144 plus 25. That's the square root of 169, which is 13. So AB is 13. BC is going to be the square root of 6 squared plus the square root of negative 9 squared. So we go in there and that's going to be 36 plus 81, which gives us the square root of 117. And that doesn't simplify, and for our purposes, it's actually fine to leave it like this today. All right, and then AC, we've got the square root of negative 6 squared plus negative 4 squared. So that's going to be the square root of 36 plus 16, which gives us the square root of 52. And I could actually simplify this, but I'm going to show you why it's not necessary. So we can figure out one piece of information so far because we've got 3 different lengths, right? 3 different lengths means that our triangle is scalene because all the sides are different lengths. So that's one way you can tell the side lengths of the triangle and how to classify the triangle based on that. Then we want to classify it based on angles, and for this we're going to use the Pythagorean theorem. So we're going to take the 3 lengths of our triangle and we're going to see if they work in the Pythagorean theorem. Because if we have 3 lengths of a triangle that make the Pythagorean theorem true, then that definitely means that we are going to have a right triangle. So what I need to do, because I know that the Pythagorean theorem is a squared plus b squared equals c squared, and I know that a and b have to be the short sides of the triangle and c have to be the hypotenuse, I have to identify which are the short sides and which are the hypotenuse of this triangle. I do that by looking at this row right here. So I say, well, the square root of 52 and the square root of 117 both have to be smaller than the square root of 169. So I know that these two are A and B, and I know that the square root of 169 or 13 is C, since that's going to be the longest side of the triangle. So I'm going to go in here and I'll put these in. So I'll take A squared, so I'll say that's the square root of 117 squared plus B squared, and that's the square root of 52 squared, equals C squared, and that's going to be 13 squared. And then I go through and I I evaluate the Pythagorean theorem. I'm looking for the left side versus the right side. So here I have the square root of 117 squared is 117 plus 52 equals, and over here 13 squared is 169. And then I have to check if 117 plus 52 is 169. And indeed, if I add those two together, I get 169 equals 169. And since the Pythagorean theorem works here, it makes this expression true, then I know that this triangle has a right angle, because the only time the Pythagorean theorem is true is when we have a right triangle. So I know this is a right triangle. Right? So that same process, and we can say because here, because a squared plus b squared equals c squared. Since they're equal, we know it's a right triangle. The same process is what we're going to do for the other two triangles today, even though these are not right triangles, and we'll see how that works in a minute. So we'll come down here and we have 3 more vertices, and maybe we can label those. We can call them A, B, and C, so it's easier to talk about them. And we're going to find, the same as we did up above, we're going to find the side lengths of this triangle. So we'll say here's side length AB, and side length BC, and side length AC. So we'll use that distance formula here, AB, so x2 minus x1, 7 minus 4 squared, plus y2 minus y1, 1 minus 9 squared. Same thing for BC, we'll plug in those numbers, so x2 minus x1, negative 3 minus 7 squared, plus y2 minus y1 is going to be 6 minus 1 squared. And then AC, x2 minus x1 is negative 3 minus 4 squared. Y2 minus y1 is 6 minus 9 squared. And then we go through and evaluate these. So here, we've got the square root of 3 squared plus negative 8 squared, which gives us the square root of 9 plus 64. And if we evaluate that, that's the square root of 73. Once again, we don't need to actually evaluate this. We can leave it in square root form. Then for BC, we've got the square root of negative 10 squared plus the square root of 5 squared. That's going to give us the square root of 100 plus 25, therefore the square root of 125. And then we've got AC, which is going to be the square root of negative 7 squared plus negative 3 squared, which gives us the square root of 49 plus 9, or the square root of 58. So if we look at each of these, we see that it is 3 different side lengths. So we know that this triangle is going to be scalene again. None of those side lengths are the same length. And then we need to check what kind of triangle it is. There's a hint up here. It's probably going to be an acute triangle. We're actually going to use the Pythagorean theorem here as well. So we're going to use the idea that if it's a right triangle, then a squared plus b squared equals c squared will be true. But if it's not a right triangle, then that won't be true, and that's going to help us as well. So we'll look for our smaller two sides, and I see that my smallest sides are the square root of 58 and the square root of 73. So I'll say the square root of 58 squared plus the square root of 73 squared equals, and then over here it's going to be 125, or the square root of 125 squared. Then we evaluate all of these. So again, if you take a square root and square it, that's going to be 58 plus 73 equals 125. And then we're evaluating on this side. So 58 plus 73 is 131. That doesn't equal 125. 131 is bigger than 125. 131 is greater than 125. Oops. So if your a squared plus b squared is greater than your c squared, that rule, this is something to memorize, a squared plus b squared is greater than c squared, that means your triangle is an acute triangle. Okay, that means that all 3 of the angles in that triangle are acute. So if you were categorizing this triangle, it would be a scalene acute triangle. All right, and again, there's not There are reasons for this, but there's nothing that we're going to go into in this class. It's just something to memorize, as if their first two terms add up to more than your c squared, then that's going to be an acute triangle. You can probably figure out what's going to happen here in the obtuse triangle example. We're going to work through this the same way we worked through the others. We'll say that these vertices are maybe A, B, and C, and we'll go ahead and find their lengths. So AB here, BC, and AC. The square root for AB, square root of 0 minus negative 6 squared plus 6 minus 2 squared. For BC, we're going to use square root of x2 minus x1, so that's 6 minus 0 squared plus y2 minus y1, so 2 minus 6 squared. And then AC, x2 minus x1, 6 minus negative 6 squared plus y2 minus y1, 2 minus 2 squared. Then we'll evaluate here. So I've got the square root of 6 squared plus 4 squared, which gives me the square root of 36 plus 16, which is the square root of 52. Then I've got the square root of 6 squared plus negative 4 squared, which gives me the square root of 36 plus 16, which again is the square root of 52. And then I've got the square root of 12 squared plus 0 squared, which again is just the square root of 144, which is 12, but I can leave it like this because I do like to see all of my side lengths in the same way, because that can help me figure out what are the short sides and what's the long side. So if I look at these lengths right now, I can see that this triangle is going to be an isosceles triangle because two of the sides are the same length. So this is an isosceles triangle. Isosceles, and then we have to test it to see whether it is right, acute, or obtuse. We're again going to do that with the Pythagorean theorem. So we are going in expecting a squared plus b squared equals c squared. That's what we want to happen, because when we use the Pythagorean theorem, we want there to be a right angle. There might not be, but that's kind of what we're expecting. So we put in our a and b, our two short sides here. So we've got the square root of 52 squared plus the square root of 52 squared equals c squared. So that's going to be the square root of 144 squared. And then we evaluate. So we say, well, this is 52 plus 52 equals 144. And then we know that 52 plus 52 is 104. That's not equal to 144. 104 is less than 144. And this is the rule about obtuse triangles. If a squared plus b squared is less than c squared, then you have an obtuse triangle. One of the angles in your triangle is obtuse. So we'll write that down. If a squared plus b squared is less than c squared, then that is an obtuse triangle. So this triangle is an isosceles obtuse triangle. So we can calculate and we can categorize like that without ever using graph paper, without ever seeing those triangles written out. So with your homework tonight, you should be doing a whole bunch of these, trying to categorize different triangles. If you have any questions, feel free to message me. All right, thank you. Have a good day.